last session of the day. A long day for you, for me too, for different reasons, but let's not get there. My name is Licia Floro. I've been working on the EOSC future project for a while. Oh, yes, sorry. Of course, I also need a mic. Yes, okay. So I've been working on the EOSC future project as activity leader for the architecture and interoperability work package. What we would like to show now is really something that's a bit more maybe technical, let's say, to show a little bit more about the details of what we have been doing so far. So the session is a bit, it's not only about, actually I will be talking very little, which is good. What we want to do is to talk about a little bit and present the EOSC platform. You all know what the EOSC platform is, right? Because you were all listening. You do know, Ron, of course. But if you have not been at the other sessions, you will see now some diagrams that hopefully will clarify everything that Mark will be presenting. Then we will talk also a bit how we work in parallel. We had identified some interoperability patterns. At least we try to create these patterns to facilitate the work. And now we are mapping things really on the architecture with the diagrams to see what is missing and what is needed. And then we will try to show you some examples of what we call interoperability guidelines and the work that is ongoing. We start from the EOSC core services, so maybe I should go a little bit here before we get to the example of the interoperability. You have seen this picture, I believe, for 2 years, something like that. And actually, this was a good picture. That's why we kept it. Probably this came from you, Mark? No. So here you can see the patterns that we have defined, that we had identified when it comes to interoperability. There is the EOSC core platform, and that is, or the platform as we want to call that includes a number of services like the accounting, the monitoring, help desk, metrics, the registry, the marketplace. There are some things that should be included, the PID services, where we are not there yet. Some knowledge-based registry. There is the EOSC AI Federation, which was presented already, and probably is now, there is something ongoing in the other session at this moment in time, but you will hear something more. So, and then in addition to that, to this, there is the world that already exists before the EOSC project or the EOSC came into place, the clusters, the infrastructures, research services, and how these things have to work together. So we are focusing at this point in time on the interoperability with these core services, and that's because this is something that we believe we could control a bit better, because it's something that we have people, we have access to people, one being here, Pavel, and the other one not being here, but being represented by Pavel as well. So, and they can tell us a little bit, they can tell us a bit more on what we are doing. So with them, whilst they focus on the development of the services, we look at the interfaces that these services are needed so that they can be used by others if needed. It's not mandatory, it's a plus. In addition to that, there is also the interoperability between our existing clusters, bigger research organizations that want to interoperate with, maybe use some of the core services, and at some point it would be nice if we could collect some statistics about all the EOSC ecosystem. Some of the statistics will be provided by the clusters directly, but then at some point you will want a sort of an aggregation point to see what works and what does not. So, and then there is, of course, the existing and ongoing interoperability between clusters. Of course, they don't need the EOSC. Some of the integration and interoperability is bespoke and will remain bespoke and will continue. But we would like really to piggyback on that bespoke work that was done and identify the patterns so we can promote those patterns in guidelines so that others don't have to go through the same process over and over again. And then there is let's say the simpler case of a research service that is then interoperating with the infrastructure services and so on and so forth. At the moment, what we want to focus and what we will present today mostly will be the interoperability A and B. let's say, and we have examples about guidelines for these services. We have also examples, as I said, there has been a lot of work in the past years done by the communities where there are guidelines in place, frameworks in place. And one of these examples is the AI. As you know, there was the ARC project before, there was a lot of activity ongoing, and there are frameworks there that will have to be adopted by the e-infrastructures that have an AI that wants to join the EOSC AI Federation. We are not going to reinvent any wheel. We'll thank the work that's been done before, and we will promote that as the interoperability framework for the AI. So you will see a bit of example reusing from the community, building, and something in between. But before we get to that part, we would like also to show to you the work, the more in-depth work on the architecture. And this has been, well, it took some time to get there because we needed also to understand a little bit how to proceed. It's kind of an overwhelming system if you look at the old points. But now finally we found an approach and a method that's based on the C4 methodology. Maybe we'll say something, Mark, in the slides? Yeah, okay. And Mark will show you where we are, basically starting from a higher point in drilling down and exploring more into the various components to identify these patterns. So I will stop here because I think Mark has got more interesting slides. Maybe just one last thing I wanted to say before I stop. You have seen these slides before, so I will not go along. I will not be very long here. Mark presented this morning and did it very well. We have now a framework in place that encompasses a methodology where we can collect everything, how we can promote things that already exist as EOSC guidelines, etc. I don't want to spend a lot of time on this because you have seen that before, but if there are questions, of course, we can answer to those questions, because I would like really to go more on the more practical aspects of the guidelines, the services, and the architecture. So if there are no objections to that, I'll lend it to Mark.
Okay, I will stand over there. Okay. I'm Mark van Zander from...
Speaking the mic.
Okay, no problem. Everyone can hear me? Okay, thanks. I'm Mark van der Zanden. I'm from SURF and also from EUDAT. And within EOSC Future, I have been working very much also on the EOSC architecture and on the interoperability framework. In these slides, I want to go through a little bit of evolution of what we have done on the architecture. If you were at the session where also Klaas Wienengel was presenting, then probably these slides will be somewhat more familiar because he took them from this presentation. But this is about the evolution. So if you look at where we started with EOSC before EOSC Future, we had the EOSC Architecture Working Group, and there we were developing also on basis of the information what we got from the Sustainability Working Group on what would be then the EOSC architecture. See what they defined as what the EOSC core components would be or the frameworks would be. How does this fit within a platform? And for this we developed these diagrams where you have on the left side an overview of how to define what the minimal viable EOSC or minimal viable ecosystem is. And what you can see is that this is a slice of what the whole EOSC is, because to be viable does not mean that you need everything, but you need a minimum set of the basic components, a minimum set of resources being provided through, but also a minimum set of users making use of those resources, because else the whole ecosystem is not really viable if you have no users. Next to this, we also looked at what are the different components being described or suggested by Sustainability Working Group. How does this fit within a whole platform? Where you have users on the top, because you need users, but also you need providers making those resources available through a platform so that users can discover which kind of resources are made available. And in this context, if you look on the left side, there are different kinds of resources made available, not just services, but also different kinds of data, resource products, but also resource products in publications, research data set, but all kind of artifacts, research artifacts, which can be made available. And you can think about this in a very broad sense, what kind of those artifacts could be. From this, we went to this level of architecture diagram, which we produced as part of the development for the EOSC Future project. So that is really at the start of the EOSC Future project. There you already see also the different kind of components, but also how they were mentioned within the Sustainability Working Group, defined as we have the EOSC Core, we have the EOSC Exchange, as EOSC Core as the basic platform, and the Exchange, the framework in which resources are made available. And if you look at the right side, also the EOSC interoperability framework. That is the set of guidelines which you want to promote throughout EOSC, so that you can support interoperability across different domains, across different kinds of services and resources made available. On the left side, you have supporting activities, because there's a distinction between what is really core, what is as a minimum what you need, but you need also supporting activities so that you are allowing researchers, but also research communities making use of those platforms. So supporting those different kind of users of the platform, that you provide added value to those users. On the top side, you see also the different kind of communities who can make use of this platform, how to make resources available through the platform. But you see that also at the top side, because the communities have different kind of resources which are very specific to their community, but they can also offer resources through the EOSC platform. Does not mean that all the resources, all the components, all the services or data they have should be part of EOSC, but what they want to provide through EOSC can be provided through EOSC. And that is at the decision of the research communities themselves. They can decide on this, what to make available. If you look at the lower side, you also see that different kind of projects, for example, as DICE, EGIA, C-Scale, Reliance, and OpenAir Nexus. Those are projects which are called 07 projects, because they are projects based on providing resource on basis of virtual access. So they can be offered free at the point of use, while the research providers providing those resources are reimbursed by the EC of providing those resources. And on the lower side you have the different EF structures, because these already are providing generic services to the different communities as part of the horizontal services. From here we went to a different kind of modeling, because what we discovered also in EOSC Future is that every different development team, every different person which wants to present EOSC was using different kind of modeling of describing those kind of diagrams. Different kinds of names, which was very confusing, because in one session it is called this way and another session it's called something else. But essentially they were the same. So to make it a little bit more compatible with each other, we looked at to see, okay, how can we improve the description of the architecture diagrams? And for this we went to the C4 model. And the C4 model is a very interesting model because it is hierarchical, so you can go from high level to different levels beneath in describing in more details what you are able to describe. And it is also that you have to describe those diagrams in more detail. So be more descriptive, not just simple boxes, but provide descriptions on all these boxes, but also on all connections, so that the diagrams in itself are more self-descriptive, so are readable if you do not have a long deliverable need to read through to understand the diagram. For implementing this, because it is really a model, so we need also tools for implementing. For this we went to ICE panel as a tool for making those diagrams, and you will see a number of examples which shows and explains, okay, what we have done. Within the ICE panel tool, it is fitting on the C4 model, so you have the different layering. You can go drill down to a more detailed layer of the architecture on the different components. But also there are some added values to this, that you can describe, for example, different kind of data flows within the model. So you can take a diagram, replicate this, and describe, okay, for this kind of capability provided within the architecture, this is the data flow. And also there I have some examples. So for us to start at the highest level, we described the EOS platform as one single box, but more to describe who are the stakeholders on this box, so that you have a consumer side, which you have also different kinds of consumers. I will also show this more in detail. You have the service providers, resource product providers, but also, for example, we have external catalog owners, which do something similar as what we will do in EOS platform, but for their own community or for their own national organization or country, providing those kind of capabilities. So if you drill down, then for example on the consumer and the provider side, then you can define also different kind of those stakeholders, these different actors. And we have defined this as research communities, so the RIs, which are larger communities, individual researchers, but also, for example, a special case as citizen scientists, which are not directly affiliated with the community, but are contributing to science. And you also have commercial entities, which is called, which are able to make use of the resources made available through the EOS platform. On the provider side, you have also a wide range of different kinds of providers. And at the moment they are categorized as the E-infrastructures, which you saw as providing horizontal services. Research infrastructures, because they can integrate and make their resources available, which they want to make available. You have the private sector, which can provide commercial services on basis of what kind of added value they can provide for the research communities. And you have other, and that depends on what can be other. Can, for example, national organizations or external catalogs making resources available from their own domain. Then we go to this level of diagram, because there are a lot of components and you can drill down, and this is not even the lowest detail which we have, because all these components even can go in lower components. And if you were in the previous session where you see also all these different components, you already saw that many of the components have already additional components. Therefore is an additional layer where you want to drill down to. But with this one is that at the immediate layer of this, you can already identify, okay, what are the different components into play. And what you can see, for example, what you can see if you look at, for example, at a community or an E-infrastructure, they already also have their own platform, where the interaction is for different kind of capabilities, different kind of functions. So not just only onboarding a service, but also that you can provide a support channel, so that you provide a help desk to those users, but also that you have your own catalog where you already register your own services made available to your own community. And for this, if you want to, for example, onboard resources, then different components of an infrastructure, of an organization are in play to make this onboarding happening. And this is what we will try to do also with this level of diagram, to go in a little bit more detail as, for example, what an E-infrastructure or research community is organized, because these have similar organizations. You also see, for example, the EOSC Exchange as one area spanning across different organizations, and those are the resources made available through the exchange. But if you look at also the other services from the infrastructure and the communities, not all services are mandatory to be made available, so they are also outside of the infrastructure. And those type of things we can model within this diagram. You see also many different arrows going from many of the different components, and we can use those arrows to define, okay, for which context they are being used, but also, for example, for which API standards they use to connect one component to another component. And this is one of the things which we go in another level of detail. This is a logical view, And there you can see that some of the components are involved in a number of what you call definitions. And if you look at the AAI, almost all components are linked to the AAI. So they are involved in this. If you look at, for example, monitoring, then only a few services are involved in monitoring. The monitoring service itself, but also the services which are monitored. So the links towards those services are also in play. If you look at, for example, the onboarding, then different kinds of services are involved, different kinds of actors are involved in doing the onboarding of services, but also resource products into the resource catalog. And by having defined different kinds of tags within the diagram, you can easily model different kinds of information by just showing a certain set of tags in this diagram. This is on the logical view, where we have modeled the different different components and their interactions with the different components from other stakeholders, as the communities, e-infrastructures, and for example also an external catalog as the Okra framework. But we can also do this in a different way by defining which kind of standards are used to connect different components to each other. And we also did this by defining the different standards as tags within the model and label those components with the different tags which are used to interconnect between the different components. And this, I think, shows clearly what kind of standards do you need to use. And those standards are then part of the interoperability framework, where you describe if you want to do the onboarding of a resource product, then this is the way you do the onboarding of a service into the catalog. These are the standards to be used to make your data harvestable, for example, through OpenAir. And with this kind of labeling and describing, you can provide better descriptions towards you as, for example, providers, to see how do I make the onboarding or the connection with the different components within the infrastructure. A few of the examples what we have looked at. For example, if you have the user access flow, it will look at how does a user make use of a service. And because we are in the federated AI infrastructure, then you see the whole flow to see providing this type of access. And you can model this in this flow. And by going through the different steps, you see what is made available to do this. One of the other services we're also working at is a data transfer service. And the data transfer service is providing capability of moving data from A to B. And we provide a layering on top because there are different mechanisms of supporting the data transfer. And that will be part of the execution framework, that you have a mechanism of selecting, I have service A and service B, but they have one common API to support the data transfer, and that common data transfer API is supported by another service steering the data transfer. For example, what we have, for example, with the FTS service. So the execution framework in itself finds out what is the best method of supporting the data transfer between different kinds of resources in between, and which are the interactions for one service to another, which APIs are to be used to make those connections. And if you looked at the different steps, you can see how this is modeled when the user wants to make use of this. So starting from the top, the resources, researcher is finding some kind of data within the catalog, selects this data set, want to move this to another service where the other service is also found in the catalog. Then to make this happen, then you can go to the data transfer service. It knows where the source is because you find the data set at a source, and you know what the destination is by providing the additional information how to get access to the destination. You can initiate via the data transfer service that the data movement is happening between the location where the data is and the service where you want to move the data to. And at the end, the researcher knows when the data transfer has been finished and can start doing the analysis on the location where the data is being stored for doing computing or other kind of analysis services. One of the other things is that because we have many different components, we want to go further in modeling those components within this model so that we have a more extensive model to be used. And if you look at the previous session, there are many different diagrams already for the different components, and we want to model this in this ice panel model on basis of C4. Therefore, we want is for us to harmonize those diagrams so that we can also better use this, but also create clearer pictures towards the different users to look into what our architecture is. And at one of the end is also that we want to provide an EOSC architecture document, because at the moment the EOSC architecture is described in many different deliverables, and therefore bring this together in one document so that it can be used as a reference document. Then it helps at least the users to better understand what the overall architecture is and how to make use of the different components within the architecture being provided. Okay, this was the final one.
Very good. Then, are there questions for Mark? Have you all got the diagrams, or you trust that they will be good?
Actually, I quite understand everything, but I still have some kind of reservation.
And now for the tricky questions.
Yeah. No. I'm working in this area, so this diagram for me is just some kind of student exercise. Okay, so, but I still see, I commented in the first session on futures, EOS future infrastructure, that this diagram, this vision, missed one important aspect, is a user layer. Because you operate this user access, but in fact, we need to provide the research environment with multiple users. So we need to provide the whole set of services that a project manager will add multiple users and so on. We did this in some different projects. I don't even remember what. But I will something show in my presentation.
Okay.
Okay. So
good. Thanks.
We'll wait for your presentation. Then we'll move to others. Oh,
sorry, just a small question.
No, it can be long.
It's a small one. Are these diagrams available? Can we see them somewhere, or are they not yet open?
At the moment, they are not yet open, and they are very much still also contained into the application. But that is one of the things that we want to make those diagrams available, and also that is one of the ways of describing this as part of the EOS architecture document to make those available.
Oh, perfect.
The point is that the application is also a bit tricky, and because it's a paid application, so so we have to. But we would like to share them somehow to get some feedback or to organize some sessions on those.
Okay.
Then we move now to the core services, and Pavel will represent two because we couldn't manage to get Kostas here and online, and Tevis is in another session, so Pavel will take care of two services.
Wrong presentation, I noticed. Okay.
Okay, my name is Pavel Weber. I'm not Kostas. I was asked by monitoring colleagues to present this presentation, and I will go through slides. And after I come to help desk. So the context for these presentations is the prepared interoperability guidelines, 2 documents for monitoring and for help desk, now available in Zenodo. And so I think we will go a little bit in detail about them. So, starting with the monitoring service, this is introduction slide where we see that EOSC monitoring service is the service which emulates the user behavior to monitor the resources and to provide different kind of information like real-time status reports, availability, reliability reports, real-time alerts, and it also implements the topology of the infrastructures, relationships between services and dependencies, what is basically available. If one component is not available, the whole service could be also not available. And at this point, I also would like to say a few words about why in EOSC the vision is to ask providers to integrate with monitoring service. So we heard about benefits many times and other really benefits, because I heard also many opinions that actually if the provider is big, they typically already have a monitoring system in place, local monitoring, why they should, in addition to integrate with EOSC monitoring. And also for small providers, if there is one service, basically there is some scripts which already also deliver this real-time alerts and if something wrong with the service. So I think my personal opinion is it's not about the benefits, or if we are talking about benefits, we can talk only about long-term investment. So you could see benefits in maybe in multiple years, but the major point here is to contribute to the EOSC, to contribute to the establishment of the EOSC ecosystem. And by doing that, you make your service also available and visible in the system, in the EOSC system, and also makes EOSC system a bit stronger. So far is about motivation, and now I come to next slide, which demonstrates just two portals. One is for core monitoring, for EOSC core monitoring, another is for EOSC Exchange monitoring, and start with the integration options which are described in this document. So the first option, already they were multiple times described, so I'll probably just repeat very fast what are these options, just to remind you. So this is the major option where the onboarded service is integrated in the monitoring system. Basically that happens during onboarding process if provider would like to do that. The next option is the monitoring of the infrastructure. So if the provider has the infrastructure, the provider could bring the infrastructure topology in the monitoring system, and it will be shown, it will be basically the community instance will be delivered for provider, a dedicated community instance, which will provide the monitoring information for the infrastructure of the provider. The third option is the integration of the external monitoring service. So in this option, you bring your monitoring system in the EOSC monitoring. So you have some data from the system already available, and you just provide this data for the EOSC monitoring system for later consumption. The fourth monitoring option is basically other way around. So if you have some services which have some dependencies on the EOSC services, and you would like to monitor this EOSC components, and so you can get this information via the API and use it as you would like to use it. So this is an example of the achieved integration, and there are some reference documentation. I think that's it. Yes, that's a short presentation. I don't know if you have any questions, or I can continue with help desk presentation. Okay, so I will. Yes.
What kind of processing tool do you use for monitoring data stream? Is a batch or stream or what?
Oh, this is.
It goes a stream of log data, monitoring data.
Chris, do you know that? I
what
think
do you do this
we have, or Mark, I think I don't know that details, this technical.
The monitoring is based on Nautilus and Nautilus probes, and it will analyze the user access, what the normal user would do.
Sorry.
So it will, okay, the tool which is used is Argo, but it is on basis of having Nautilus probes, and the Nautilus probes will simulate user access. And you can have different kind of protocols, so you can have different kind of probes for different kind of protocols to replicate what a user normally would do to access a service. So it is not looking at the log files, because that is more of the local side, or at the local monitoring to see if all the processes are running or the file systems are full, but it is more looking from the user perspective. Can I use this service on basis of normal user access?
But what is kind of this statistics based on which data?
The
How many users access or?
It is the statistical information is based on the probes run on a regular basis that the user or the user normally could use a service.
Okay.
So perhaps I could try to answer the question to the best of my ability. In another lifetime, I used to be the owner of that service, but I don't even remember myself. It does use a Lambda kind of infrastructure where effectively it has a Lambda streaming where it does processing in real time. Now I cannot remember the software we're using. It was an Apache project for Lambda infrastructure. So one part computes the data stream that comes from the messaging system in real time and provides an initial computation of the statistics. And another one pushes the data in a Hadoop system so that it does batch operations. So you mean
Kafka, Storm, and Flint?
Apache Flint, yes.
Okay,
we're not using. We're not. So that used to be the case. 7 years ago when I was doing that. So it might have changed, but the logic is still the same, and the question is very valid. I think this is exactly what we're doing. Perhaps the tools have changed, but that was what we used to do.
I mean, there is this components where there is a monitoring engine which basically collects this information and then sends it via the messaging, service to the publish it.
And the backend of the messaging is Kafka, but there is a front end to that, which implements basically the Google APIs for PubSub.
No, this for me is sufficient. Actually, CERN monitoring done almost identical.
This one replaced the old CERN monitoring. So if you remember the Oracle-based solution that they used to have back in the day, that was the implementation that basically replaced that. And now I know that CERN has gone towards a similar direction.
No, I mean you, CERN monitoring based on
you. I was not at CERN. I was at GML.
Okay.
Okay, so then I continue with EOSC help desk and again say a few words about interoperability guidelines. So the guidelines for the help desk aim to provide a description of the help desk, a description of the functions and capabilities, different integration options and interfaces, and also provide some practical instructions how you could integrate with a help desk. This is the document available in Zenodo, and I'm not going to basically repeat my previous presentation where I already shown this in the previous session, but just go very quickly for those who didn't attend the last session here. So the architecture shows only relevant components for the EOSC. So we have basically multiple submission modules, the back office, and which implements all the major functionality of the help desk. And so this and different integration paths. So this architecture enables integration, to implement integration options for the community help desks, also for communities who would like to use the help desk of the EOSC. I will say a few words about it later. So these are the integration options. Basically, we consider three main types of the integration. This is a direct usage, where the community just using this service, ticket redirection, where the tickets just propagated to the community help desk. So in this option, the EOSC help desk is used just as a proxy, and the full integration, where the existing community help desk is fully integrated with the EOSC help desk, meaning that the tickets are synchronized in both directions. Before I go further, I think this is the focus also of this session, and to say a few words about the interoperability. So I have to say that to achieve the interoperability for help desk is quite a complex task, and because so far we are talking only about the technical interoperability. We know that according to this paper, EOSC interoperability framework, we have multiple types of interoperability, and it's not enough to achieve one kind of interoperability to say that the service now is interoperable. So we have, in addition to technical semantic interoperability, organizational interoperability, and legal one, which I won't touch now because we need an additional session only for that kind of interoperability. So what I want to say here, that all layers should be considered when you start the integration with the help desk. And we have to understand that the organizational interoperability is basically alignment of business processes, alignment of responsibilities, workflows, and it's not also in this context of the integration with help desk, that doesn't mean that we would require from provider to align the processes according to some EOSC process, EOSC service management system. It's other way around. So we try to adjust to adopt the help desk configuration according to the requirements, according to the organizational setup of the provider. So this is an important point just to understand that we try to meet the requirements, and we don't request anything. But in both ways, actually, this interoperability should be achieved. And again, before I say a few words further, the question why to integrate and why to interoperate with the EOSC help desk. So I would like to regard two initial situations. The small provider, which basically a small group of colleagues, they have one service, one mailing list, and resources are limited. So this is the main problem for small organizations. And a big organization where there are multiple groups and divisions, there are multiple services or infrastructures, and help desk system is in place. So again, in both these cases, here everything is already in place, and for small provider, it's basically a lot of work to integrate, to adjust the processes, and maybe at first glance, it's there is no real benefits. Still, if you're talking about the benefits, for small, they're quite different. So this is, I think, we need to understand the benefits for small provider and for big provider could be quite different. So when the small provider has the main problem is the lack of resources, and as far as help desk provides the knowledge base, this is could be used to some to spare the resources, and also using the help desk of EOSC is basically makes more professional delivery of the service and could scale up the support. And the major advantage that if you use it as a service, there is no need to run your open help desk. For big organization, the benefits are quite different. As I mentioned, it's more to provide better interaction with the users, with other EOSC actors and players, to reach wider audience and to avoid working in silos. This is, I think, the main problem for big organizations. And integrating with help desk could basically, maybe not solve, but at least improve the situation. So, as I say, in terms of interoperability, if you take the first option, this is the help desk as a service, there is a minimal effort for technological interoperability because the technology in place, we offer the help desk and the provider should just come and take it. The major effort, the maximum effort for organizational interoperability, because the provider in this option should define the roles, access rights, visibility, ticket management workflows, escalation procedures, SLA definitions, all that what was missing. And this is what we refer as organizational interoperability. In the second option, the ticket redirection is more about semantic interoperability. One has to be sure which information will be, in which format will be forwarded to the provider and define exactly the format of the ticket. But actually, this is the most easy integration option to implement. In the third full integration, the situation is quite different. It's opposite to the first option where we have the maximum at organizational interoperability. Here, the maximum, the most challenging is the technical interoperability, because the organizational interoperability is minimum because provider already has the help desk. All the processes are set up. What is needed is to integrate technically to allow the exchange. This is example of the GIGAS help desk interconnected with the EOSC help desk to basically to exchange technically the information, the tickets, to care about the updates and so on. So this is here we have most technical challenges and minimum organizational interoperability. This is just an example how we basically achieved the integration with the GIGAS, with the full option. So I don't want to go too much in detail, just to say that several fields, this is the interface from the EOSC help desk, several fields are synchronized, mapped to the fields in another help desk system, so that like public field visible for users, private field visible only for support staff, states, priorities, and so on. So as far as ticket appears in one particular group, in one of the help desk, it automatically synchronized in the other help desk. So the ticket appears also in another help desk. And this brings me actually to the last slide, just to say a few words about the outlook and future steps. So we already integrated several communities, several are in progress, and our next steps is simple, just to continue to include more communities and providers and provide further customization for help desk according to the requirements of the stakeholders. And we will promise to work on this interoperability guidelines, also include other types of interoperability to make it more fully descriptive and useful for those who would like to integrate. Yes, that's it. Thank you.
Thank you, Pavle. I have just a quick question. The work that is ongoing with these communities, what's their feedback about, how easy they find the process, how difficult they find the process, how...
I think Carsten would like to comment on that, because he's
Yeah,
a representative
better, yes.
of the CESD community, and this is, I think, the best would be if not I will say the feedback.
Yeah, but we're happy. So it's taking some time, some work, but it was a very constructive process. I think we were also the first, so I mean it was a learning curve on both sides in that case. But it's working very well for us. The problem we had previously with commercial systems is that the usual business model is based around number of agents per month. That's the usual 10 euro per agent per month. That's your price fee on the market. And for Sesta, who has a number of services and each of them is managed by somebody else and all of them need to have agent access, that quickly scales up to a high price tag for not so many tickets that we actually get for our services. So in that sense, this is really, really good service for us.
Actually, this
Yes,
is good to hear.
it's the number of agents is actually not limited by in the open source technology we are using. So.
Great. Then, so we have heard now some examples of core services, how you can integrate. There are multiple patterns. There is not one prescriptive one. You showed a little bit the interoperability guideline. It's more complex than that, but for those that need that, there are more details. And now we move to the work that has been done by communities and how EOSC can benefit from that. And Christos will talk about the ARC guidelines. And by the way, I just want to stress, probably Christos will say that, also those guidelines, those were the result of 4 years of work, and work is still ongoing. So we are talking about 6 years, 7 years, no more. No, because my daughter was 8 years then of work.
So,
well, and then, without mentioning the work before that. So we are talking about 15 years of work.
So this is a different kind of presentation, as Licia mentioned. I will not talk about the actual guideline specifications and interoperability guidelines, but I will talk about how effectively in EOSC we're using the work that is happening in a different place, but in many cases by the same people or a wider set of people, and then EOSC builds on top of that. So this is basically EDGIS, which stands for the ARC Engagement Group for Infrastructures. And this is the result of a 5-year project that started in 2015 and ended at the end of 2019. And it brought together research infrastructure providers, NRENs, libraries, to try to solve a very specific and particular problem: how we can use authentication and authorization for research collaboration. And this is what ARC stands for. So the project had a number of outcomes. I will not talk about this, but about one particular, that it had a focus also to find also a way to make sure that results are sustainable and they continue to be involved after the ending of the project. This led basically to EDGIS, which is the group that I mentioned at the beginning of my presentation, which brings together effectively infrastructures who are implementing using the ARC blueprint architecture and the guidelines in order to implement AI solutions for their communities. And effectively, this body of infrastructure providers is the one who is, let's say, responsible for separating the process and the guidelines that are produced by the ARC community. So even if the project or the ARC project has finished since 2019, the ARC community is still going and actually has grown. Now the community includes experts, AI experts from all over the world. So we have contributors from Australia, from Asia, from the US, of course from Europe. And altogether, basically, we're trying to address the issues for using AI in the context of research collaboration and try to fill in the missing gaps as we identify them in the various use cases that we try to support in various implementations across the globe.
So EGIS has a formal charter. It has a membership aspect where we have full members who have voting rights, and effectively when we are doing work within the context of the architecture working group or the policy working group within ARC, the infrastructures have to come together, and through consensus they have to agree on the acceptance of given specification standards and commit to applying them to their infrastructures. So effectively, the stakeholders, those who are supposed to implement and use these standards, are the ones also who are deciding about the application of these standards for the infrastructure, their commitment to the standards. In addition to members, we have also a lightweight kind of participation, which we call observers, and they are infrastructures who do not have probably the resources yet to fully commit to the work of EGIS and ARC, or that they do not have yet the infrastructure, but they are thinking about implementing something, and they want to follow the works and be part of the discussion, but without having membership rights. Having said this, and something very important is that the actual work on the standards is open to anyone, so anyone can contribute. Only the aspect of voting whether something becomes mandatory for the infrastructures is what is regulated by the membership in EGIS. So this process goes for a few years already, and as I mentioned, we have two areas we're working, the architecture area and the policy area, and both of these areas have been providing and developing guidelines since from 2017 up to today. The way that we operate is basically that the EGIS interacts with the research and infrastructures by having them also as members. Use cases are being drawn from the research communities, from those who are implementing and using the AI infrastructures. And also we are interacting with another very important community, which is called FIM4R, which is perhaps the community that spawned everything up back in 2012, when it brought several research infrastructures together, trying to identify the problem of how do we use federated access in the context of research collaboration. And this FIM4R collaboration is active until today. It has already published two very important papers, which have actually set the strategy of the European Commission also in terms of funding towards the AI aspect. So it is a very powerful tool, and has already been adopted by infrastructure abroad. So we have the US with Internet 2 adopting the papers of FIM4R and making sure that they can also deliver these capabilities that are described in these papers. So working very closely together, trying to establish a loop where effectively we are designing solutions based on requirements driven from use cases, and then feed them back again to the community to get again feedback and continue this work. So this has been happening way before EOSC was EOSC. So it has a long history behind it. And right now, today, for the architecture working group, Nicholas, who's sitting over there, and myself are co-chairs. And we have also the policy area where our colleagues David Group and Dave Kelsey are chairing this aspect. So up to today, the ARC community, through the EGIS process, has already went through 14 such distinct interoperability guideline documents. And you can see that the first one was back in 2017, and we are active up to recently. And I think we have already in the pipeline another 3 documents that will be coming very, very soon. So this is a continuing process, ongoing process, and it takes some time to make this happen. It is not just a few people getting together and make a decision and writing a draft, but it really requires international consensus beyond Europe to be able to get to this list. So it takes some time. We had documents that it took 2 and 3 years until they made it to the final stage for wide adoption. So there is a lot of work and a lot of mechanisms behind the scenes working to be able to make this available, and this is something that we want to build upon within EOSC. Perhaps I can say a few words about also the process that we're following there. So we have a very clear open process within the ARC community of how we develop guidelines. Not all of them have to be EGIS approved. Not all of them have to be approved and become mandatory for everyone. It might be some very specific topic which might be niche that does not require full horizontal acceptance by everyone and might be beneficial for some, and some people might be keen on working. This is fine. We also have the concept of informational documents that do not have to go again through acceptance because it is just for information purposes, like best practices documents. But the interoperability guidelines do have to go through a very strict process for acceptance. And perhaps the most important aspect is that it has to be consensus. It is not based on majority decision. All of us will have to unanimously agree, because even if one infrastructure say, I will not do this, then interoperability goes outside of the window. So this is a difficult process. If you go to this link, you can find more information about how we do and how we deal with this process. And this brings us to the EOSC part of the story. So when we started with the EOSC AI Task Force, before the one that is running right now, actually in the context of the EOSC Secretariat in the period of 2019-2020, there was one activity within the architecture working group which was about the EOSC AI. And what we were tasked there was to do is define what the EOSC AI is and what it would look like. And from the very beginning, we recognized that we are not going to reinvent the wheel. There is a lot of work happening in many different places. There is no point to come and say we're throwing everything away and we're starting something from scratch. Although sometimes this is tempting to say, but actually it's a wrong approach. We need to build on our previous work. So we recognize this, and basically the main goals that we have set is that we build on top of the ARC blueprint architecture. This is effectively our baseline, and on top of that, what we do in the EOSC AI Task Force is try to develop how the AI for EOSC will be looking like by implementing these architecture guidelines. And in addition to that, in many cases, and this is now what is actually happening, the EOSC AI Task Force is the one who is driving developments in ARC. Because of the use cases that we see within EOSC, the experience that we get right now in the EOSC Future Project for developing the EOSC AI, we recognize the requirement for new interoperability guidelines, new areas that we need to work, and we bring them back to the ARC community to make sure that this become not just European interoperability guidelines,